So here is an example of a second order differential equation with simple harmonic motion. Particle obeys simple harmonic motion with the differential equation x double dot plus 9x equals 0. Now x double dot is another way of writing d2x by dt squared, and when we get to it, x dot is dx dt. It's just mathematical shorthand. At time t equals pi on 3, the particle's position of x equals 0.4 and also has an initial velocity of 5 meters per second. So, the first thing we're told is to solve the differential equation and to find the time that the particle has a position of 0.2 meters from the equilibrium position for the first time. So, I'm just going to go start the solution now. So, the first thing, I'll just write down that this is x double dot plus 9x equals 0. So, if we let m equal dx dt, then m squared plus 9 is 0. And so m is plus minus 3i. Therefore, we can say that the general solution occurs as x is a cosine 3t plus b sine of 3t. Excuse the dog in the background. So the first thing we're told is that at x is 0.4, we're told that this occurs at t is pi on 3. So 0.4 is a cos, well, 3 pi on 3 is just pi plus b sine of pi. Now, sine of pi is 0, cosine of pi is negative 1, and so from this we can deduce that a is negative 0.4. So I actually should check. So just solve the differential equation. So that's going to be our first bit. We're also told that at t is 0, because initial velocity is 5. So if we differentiate this, we get dx dt is, the 3 comes out and cos becomes minus sign, so minus 3a sine 3t, plus, again, the 3 comes out, sine becomes cos, so 3b cos 3t. We're only told what a is negative 0.4. So dx dt is minus 3 times minus 0.4 is 1.2. So 1.2 sine 3t plus 3b cos 3t. Now we can sub everything in. So 5 is 1.2 sine 0 plus 3b cos of 0. So sine of 0 is 0, cos of 0 is 1, so 3b is 5, and so we're told b is 5/3. So we now have that, and we can write that the differential equation is minus 0.4 cos of 3t plus 5/3 sine of 3t. And this is our equation solved. And that's part 1 complete. Now I did actually add an extra slide for this because it would take quite a while. Oops, that's example 2. Oops. So part 2 tells us that to find the time when it has 0.2 meters for the first time. So we're told that x is 0.2. Now again, just rewriting our equation as minus 0.4 cos 3t plus 5/3 sine of 3t, if I remember rightly. 0.4 cos 5/3 sine. Yeah. Now we can approximate this as in the form, we're going to go r cos of 3t plus alpha. So this is turning into harmonic form. You might actually recognize it as a sine omega t, but I'm choosing cos for this one, just to be different. So, if you remember, we have that the sort of r squared is 0.4 squared plus 5/3 squared. Again, taking just the absolute value. And so r is 1.33. We're also told that tan of this angle alpha is the sine over the cos. So that's going to be 5/3 divided by minus 0.4. So 5/3 divided by minus 0.4 is that, and we take tan inverse in radians, we get that alpha is minus 1.335 dot dot dot. Now, because cos is an even function, we can say that cos of negative of an angle is just cos positive of the angle, because cos is reflective. So we can turn this positive if we want, but it doesn't necessarily matter too much. We can actually consider a plus minus case here, which is quite funny. We'll just see how things go. So we can leave it as plus minus for now. And so we can therefore write this as x is 1.33 cos of 3t plus minus 1.335. So if we consider the plus case first, then we get cos of 3t plus 1.335 is whatever 0.2 over 1.33 is. Alright, 0.15. Do a cos inverse. So 3t plus 1.335 is 1.4. 1.42 actually. Minus, so 1.42 minus 1.335, and then divide by 3. We get our first value of t as 0.03 seconds. Plus any amount, we can actually have this as any 2 pi n, but we're not going to consider that. So now we'll do the minus case. So we'll then have cos of 3t minus 1.335 is 0.15. Again, cos inverse. Now if we instead add this time, so 1.42 plus 1.335 divided by 3, we get t as 0.92. Which looks to be a couple period cycles after this. So we're actually just going to consider that this is the time taken. So although tan here is negative, because cos is reflective, and therefore you can take the negative out of it, we would consider this to be our solution. However, I wouldn't see a whole problem with assuming that 0.92 would also be a valid solution.